Hello everyone, my name is Kevin Guzman, and I'm constantly surprised by how far the construction industry has come in terms of technology and excited to see it prosper. Today I'm going to present a paper, BIM applications in the operation and maintenance management of sport infrastructure. The goal in this research paper is to propose a BIM facility management workflow based on lean principles to compare with a traditional facility management practice using a case study. According to some authors, the operation phase is the most expensive and largest phase in the whole life cycle of a building. For example, only in the design stage, the project spends near 5% of the total cost. In the construction, spends 15% of the total costs. But in the operation phase, there is the most expensive cost, near 80%. So we can have a huge impact in this stage. Another thing is the information used in this phase is still based on paper. As you can see in the photo, there is a file boxes, papers, information from the design and constructions, and the people or facility management team trying to find some specific information. And moreover, according to some authors, this information is delivered to the facility management team or the owner after 4 or 5 months after the construction has finished. So we can see information management issue in this phase. I wanted to show you this matrix that study the interaction between BIM functionality and lean principles. It's relevant for our study because these interactions can support the actual facility management practice. For instance, one BIM functionality that's main important is effectively location building components that means used to reduce cycle times. For example, one facility management staff want to try specific information, they can access to the right information, to the BIM functionalities, and finally it's optimize the resources. Our case study is Aquatic Center. It's one of the venues of the National Sport Village Videna here in Lima, Peru. This project was for Pan American Games Lima 2019. From the design until the construction phase was under a collaborative IPG environment among the other projects. We choose this venue because its complexity, it has many systems, but in the research we focus on two, the climate and pool systems. And the venue has three kinds of pools. There is a competition, training, and diving pool. But these two systems has the main system to ensure appropriate operation of the venue. Between them, there are nearly 200 components. For instance, there are chillers, pumps water, and especially for the pool systems, there is a full treatment plant for cleaning pool water. During the operation of the sport infrastructure, several types of incidents and system failures occur. To solve this, the facility management uses a traditional methodology to schedule the corrective and preventive maintenance activity. This methodology started, for example, reviewing the maintenance plans or procedures from this equipment, from these components. After that, these activities were scheduled, and finally, this work has been executed for a subcontractor team. And all this information was approved for the facility management, but finally this information was delivered and was stored in a physical and digital base like this. So we identify some trouble because when the facility management team needed to know the activities status or tracking these activities, they can or they need to review all the process or find some information like this. After we identify the traditional methodology, we propose using both methodologies, BIM functionalities and Lean principles, to improve this facility management practice and to compare with this traditional. In this case, we propose this workflow. When you use this tool, this is a facility management tool to integrate all the information that need to this stage. This tool automatically creates a work order to tracking to performing those activities with all the stakeholders, like the facility management staff and the subcontractor teams, and finally all the information make it in this process was stored in the same tool. This is beneficial because we can update information and we can access information whenever the facility management needs. Also, this facility management tool needs both inputs, the BIM model and the COVID data. Both of them are relevant to deliver the right information. The BIM model gives as-built information and geometric information, and on the other hand, COVID data or COVID standard that main purpose is to exchange information between design and construction phase to the operation. So we use this standard to deliver all the information generated in design and construction. As part of the proposal, we define many functionalities that can support the facility management. The location building component was one of them that can enable the facility management staff to access array information faster and quicker using a single communication system on site or on office. Another was visual management. That was important because all the knowledge need to transfer to the final facility staff. So in the training sessions, it was supported by the BIM model to have a clear understanding. And what are the research findings that we need to know, or I would like to show you? For example, the aim was compare the proposal with the traditional methods. So according to the information stairs, our proposal was stored in the cloud whenever the facility management team can access, and the traditional method only stores in file boxes, in physical boxes. The information presenting, the almost information in the traditional method is paper-based to the drawings. In the other hand, we propose use a 3D model, and moreover we use a COVID standard that is an international standard to exchange information. And what about information recording? All the information, like I mentioned in the traditional methodology, work reports or checklists in paper based on in papers. In the BIM FM4 the proposal, we are able to track all the activities into the BIM systems. And I think the most important is the accessibility to the information. In the traditional method, there are a lot of wasting time searching information on papers, between in the file box or in this information paper base. But for example, in our proposal, the searching is too easy because we use a unique system communication like a tag to be capable both on site and on the system. Another advantage is that we can navigate into the BIM model to identify conditions to the activities, and other functionalities that we can link into external relative files to access the information. One of the main findings was the time saving per incident. We analyzed the traditional against with the proposal. So we identified the main difference in these activities: understanding the bed, searching the information, and recording and data uploading. And with these breakdown activities, we can identify the difference in the performing all the facility management tasks. So as a result of that, we identify 20 minutes of time saving per instance. We can, in a whole year, we can have hundreds of incidents, and we imagine what's the means in the optimized resource. Moreover, we found limitations and barriers in the research. First of all, there is a lack of BIM requirements to the operation phase. That means we found the construction model or the as-built models inappropriate to the operation phase. We need to do reworks. And the other thing is there is a need for qualified staff in BIM tools because there is always that thing, the component that need to upload in the model, like location or add some features. And finally, when we started the researcher, there is a lack of other other benchmarking or other projects to prove the positive return of investments. Finally, uh, we developed two main conclusions. The first was uh, the proposal improves the efficiency and productivity of the workforce in the facility management because they have a complete and integrated information platform. That means that all the facility management staff uh, can access to the information both in on site and on office to perform activities. And the other thing is the interaction between BIM facility management, BIM functionalities, and Lean principles is relevant to support the proposal because it promotes collaboration in the whole life cycle of building, exchanging complete and appropriate information with stakeholders. That means we use these methodologies, both BIM and Lean, to support the proposal, using principles, using functionalities, finally to improve the facility management practice. The last was our recommendation to the future work. We identify other BIM functionalities like real-time monitoring or building management system or BMS integrate with BIM to support to improve the facility management practice. So for us, it's important to continue this study or to continue these BIM functionalities to find other benefits to the facility management. That was our presentation. So now we can receive some comments and questions. Thank you very much.